Hello everyone, welcome to Product Science. In today's video, we will look at how to use Excel modeling to optimize costs in order to manage airline schedule disruption. Now in the screen, you can see that there is a schedule of 10 flights, the number of passengers booked in M class, which is economy class, C class, that is business class, and what happens if each flight is cancelled. Now if each flight is cancelled, not only do the M class passengers get a refund of 300 euros and C class passengers get a refund of 500 euros, but we might also have a change in the number of available crew. The positive numbers show that there will be an excess and the negative shows that there will be a shortage. Now if there is a shortage, we need to pay an amount of 2,500 euros per cabin crew that we have insured. We also know, however, that because of some technical issues, out of the 10 flights, 3 of them have to be grounded. However, all the 3 are very similar in terms of the physical aircraft. So we need to choose which of those 3 flights on cancelling can result in minimized cost. Now let's see how we can model this on Excel. I have summarized the data from the problem in this table. The cells in gray on top and in white here are constants, which is known data. The cells in yellow are the decisions that we are supposed to take, and that's why we call them decision variables. Now what I did was use binary variables, which means they can only have 2 values, either 0 or 1. I attached meaning to those values. For example, crew shortage, which I denote as Y, can take a value 1 and 0, where 1 means that there is a shortage of crew and 0 means either that there is no shortage or that there is surplus. At the same time, Xi is whether or not a flight is cancelled. Now Xi takes a value of 1 if flight I is cancelled and 0 if not. What is my objective? My objective is to minimize the total cost of refund to M class, refund to C class, and cost of any crew shortage. So this is what it looks like. So the first part is basically C4 being the M class refund and some product of the total number of passengers per flight and the decision that we take for that flight. Now let's see how to model constraints into our problem. So the first constraint that I would like to add is that of cancellations. Now we know that since 3 aircrafts are unable to fly, the number of cancellations should be equal to 3. So the LHS, which is the left hand side of it, is basically the sum of all decisions that we take for each flight, and we have constrained it to be equal to 3. Constraint 2 and 3 work to enforce crew shortage constraint. We know that the crew shortage variable, which is Y, is linked to the cancellations, because if the cancellations result in the available crew being positive, then Y should take a value of 0. And if the cancellations result in there being a shortage, then Y should take a value of 1. So let's assume the sum of all this multiplied by this is all equal to some value A, and we want it to be related to Y in such a way that if A is either 0 or positive, then Y should be equal to 0, and if A is less than 0, then Y should be equal to 1. Now let's see what happens. Let me create a constraint and see if it works for both the conditions. So let me say A is greater than or equal to minus m times y, where m is a very large number, let's say 999. So this means that A should be greater than or equal to some large negative number multiplied by y. Now what would happen if A were greater than 0? What possible values could y take? And y, let's put that here. So if A is greater than or equal to 0, so it can be 0 or positive, which means y should be either 0 or 1. In both cases this would hold? Yes. So we don't have much of a disambiguation on which value y should take. Okay, so that's not good enough. So let's see if we can add another constraint that can make it clearer. So let's say A less than or equal to m times 1 minus y. What would happen in the second equation is, if A were 0 or positive, then the second equation, which is this, would ensure that y would definitely take a value of 0. Because if y were 1, then this entire thing would be 0 and A would not be positive anymore. So in order to make the left hand side positive, this expression forces y to take a value of 0. Great, that means this part is satisfied. Now let's see if both these constraints will help the second condition as well. Now let's say what happens if A is less than 0. So A is negative and negative. So what happens with the first constraint? If A is negative, y should be 1. What happens to the second one? If A is negative, y should be equal to 1. See? So this constraint forces y to take a value of 1 when A is negative. So if the cancellations result in a crew surplus, then y should be equal to 0. And if they result in a crew shortage, then y should be equal to 1. So this is my model. Now let's try and solve it. Excel comes with an inbuilt solver. So let's fill in the values and start our solver. So we need to set the objective cell. So my objective function is here. So I enter that. And for me it's a minimization problem because I want to minimize the cost. And we need to specify which variables to change. So these are my variables. And also crew shortage. So I put them there. And now it's time to add constraints. So first constraint I will add is the cancellations. Now I have put the formula in here anyway, so I'm just directly going to reference it and say it is equal to the right hand side. I add that, and then the next constraint, referencing it again, greater than or equal to right hand side, add it again, and the last one. Great. Now since all my decision variables are binary, that means they can only take values of 0 and 1, I need to add a few more constraints. I need to specify that these values can only be binary, and the same goes with this. And that completes our model. So this is our model. Now you can choose a solving method based on your solution. Let's see what happens if we choose a simplex LP. Found a solution for us, and the solution is this: 145,200 euros. but we still got to know which flights to cancel. So I have conditionally formatted the cells to indicate which ones are cancelled. So flight 7, flight 9 and flight 10 are the ones to be cancelled. Now let's see if we are going to have any crew shortage. So it's 1 into 1 plus 0 into 1 minus 1 into 1. So that's 1 plus 0 minus 1, that's 0. So there's no crew shortage. So that's how we solve the problem. However, this is a very simplified problem. There could be further more complexities added to it, maybe weather feed or some real-time disruptions, some kind of flight constraints, aircraft constraints, all of that. But the way you solve it is going to be not very different from this. And see you in the next video.